fellas, how are you today? Are you okay? I really hope so. Now we are going to create our wallet in the Bitcoin with the Python, and we are going to code step by step. Okay, we are going to create our own wallet, and you can create how many you would like to without Binance and or any exchange platform to use your cryptos. Okay, you can use it on your own just with Python. So let's go. So we need to first of all create our private key, and we need to create one key with 64 types, which means 2 to the power of the 256 complexity. Okay, I'm gonna explain details to you, but you if you want, you can create those 64 types. Okay, but that's not recommended because that would be a vulnerability key to someone exploit it and get your crypto. So what we need to do, what I recommend you to create the private key with using a random way. Okay, so let's create our virtual environment first of all, because we need to install some libraries. Let's call it wallet Bitcoin. There's it. Conda activate wallet Bitcoin. It's on. At least nothing installed yet. Okay, but to create our private key, we don't need to install anything because we need just to import the OS, and the Python already have it. Let's create then our private key, import OS. The private key, it's the first, we are going to use the urandle, and it gives us in the string in bytes. It will create in 32 bytes. Random 32 bytes, which means 256 bits. Okay, it's gonna create in random, so the complexity, we can say that's exactly what the Bitcoin needs. Let's print to take a look. It's printed in the binary mode. Here is it. What we do now, we create it to the hexadecimal. Okay, there is gonna be our private key in the Bitcoin. Just convert to X. There is it. There is done our private key in the Bitcoin in hex. there is it, our key. And it represents 64 types, okay? It has 64 types, but hexadecimal. Each type means 4 bits in binary mode, like you can see here. In hexadecimal, in decimal, in hex, and in binary. 1 hex means 4 types in binary, 4 bits. In then that case we have 64. And if 1 hex means 4 bits in binary, we can say here 64 multiplied with 4, we have 256. That's the complexity of the algorithm. That's why the Bitcoin is so hard to broke or brute force and etc. So let's take a look on the math of the algorithm. Okay, if the complexity is 2 to the power of 256, it's in scaling it to the 10 to the x, we can make the calculus with log, okay? The log of 2 to the power of 256 equal the log 10 to the x. We jump, it's multiplying the log, it's gonna be 256 multiplying the log of 2 equal x multiplying the log of 10. We know it's represent the number 1, and the log of 2 it's approximately 0.3. So it's gonna be 256 multiplying 0.3. It's equal to x. Okay, and making the count. It's approximately 77. Okay, so let's say the x is approximately 77, which it means it represents 10 to the 77. That's the complexity of the algorithm we just created. So what it represents, if we take a look on the top computer here, the list of the top, the number 1, it's called the El Capitan, with the approximately 2000 petaflop per second. It's the capacity of this computer. So let's approximately to 2000 petaflop. Okay, it's if the computer it's 2000 multiplying the penta it's 10 up to 15. So we can jump this 30 and create the hexaflop 2 multiply 10 up to 18 flops. That's the capacity of the computer processing per second. Okay, we know 1 year represent 10 up to 7 seconds. Then we're gonna divide this number. It represents 1 year. 1 year. So we multiply both. Let's ignore the number 2 because it's don't represent so much in this calculus. It's 10 up to 18 multiplying 10 up to 7. We need just to sum, to plus the numbers. It's gonna give us 10 up to 25. It's the complexity of the more faster computer in 1 year. 1 year. Now we divide it. 10 up to 77 divided by 10 up to 25. It's equal. We need to make the count. It's 77 minus 25. It's 52. Now it's 10 up to 52. It represents how many years the El Capitan needs to break with the brute force or discover what's the private key in process way. It's 10 up 52 years. That's a lot of year. Let's clean this. Let's just save it here. Okay. And the university, it have 13 billions of year. That's the age of the universe. Billions, it represent 10 up to 9. Let's ignore the 13, okay? So 10 up to 52 years it's needed to break the private key. It's divided by the age of the universe. 10 up to 9. We have 10 up to 43 universe. Age of the universe. So we need 10 up to 43 universe age to decrypt this hash with the El Capitan processor. That's so much long, that's impossible to do with our actually technologies. That's why the cryptocurrency is so hard to break, and that's why it's so security. We can do more to you find out what's the complexity. We can go furthermore. We know the complexity of this algorithm. It's 10 up to 77. How many atoms the world have? It's such as 10 up to the 50. 10 up to 50, it's how many atoms the world have. So how many atoms in the world. It represent one private key. Okay, we're gonna represent it like an atom of the word. So we just need to subtract it's the 10 up to the 27. That is how many words we need to take a look to the atom to find our private key. That's very large, man. It represent one and more 27 zeros. That's no fucking way to find trying to search it in with the brute force. And that is why create a lot of wallet. It doesn't represent that you will find some one valid wallet, because each wallet represent one atom in 10 up to the 27 atoms in the words. That's technically impossible to find out. And that is what the ransomware works. They use the AES algorithm, which can decrypt the files with the complexity of the 2 up to the 256, which means 10 to the 77, and that the same way the crypto works. That's impossible to decrypt. That's why the ransomware works so well, and many companies they opt to pay back the key, otherwise they wouldn't find the key, because you will need to search one atom in the 10 to the 27 planets, and that it's impossible to find out. Now back to the code. Let's create our public key, but that public key it's one key using the elliptic curve of the Bitcoin to create it on key to make the wallet. Okay, that's key. It's to create the wallet, not the public key to use the transfer the Bitcoin, the satoshis, and so on. So let's create it, the public key elliptic.py. We need to use the ECDSA. Okay, it's not installed yet. Pip install ECDSA. Now is it? Import. We need to import the SIGIN key and the SEP256 key 1. Let's call the private key hex. It's the one we just created before. We need to pass as a string. We convert it to binary mode. We get the byte version. Now we pass it to, we need to convert it, the P key in bytes. It's just to type bytes from hex and pass the P key hex. We have it now in bytes again. As you can see. Let's continue. Now we're gonna create the object specifying the elliptic curve using the cryptography. Okay, let's call it the SK signing key from string pass the private key bytes and use the curve we just call it from the library. Okay, now we're gonna to verify the public key. S key, verify the key. Let's take a look. What is that? That's the verify, passing the SHA-1. It's the hash. Keep going. Now we're gonna create the X and the Y points in the graphical, okay? And this point represent the key to create the wallet. So SK pub key point X and the same for the Y. Let's take a look to the point. There is it. Take a look how big it's the point. It's represent the key to create the wallet. That's very difficult to create the same number and access the wallet of somebody. That's very more probably like we spoke in the math before. Now we convert it to hexadecimal. Okay, let's take a print to you take a look what I mean in hex. It's just to say that why there is it. We converted the number to the hex. Okay, that's what we just did it. Now we're gonna take a look in something specifically. Now we need to compress the code. Okay, we're gonna add the prefix and we're going to compress the public key. Let's call it prefix. We need to say if it end up with this binary, if we divided y and the rest is zero, we can say it's even, else it's odd. Then else, if it's odd, we're gonna start the compressed public key with this binary. Now let's compress it. The public key, it's the prefix plus the X to convert it to bytes in the 32 bytes and call big. Now we have the compressed public key, okay, and we convert it again, but to the hexadecimal. Okay, public key to create the wallet. We pass the compressed and convert it to hex, and there is our key to create our wallet. So now we're gonna to create our public key. Okay, we can create it, the legacy. It's the most common public key. It's started with the number one. It represents the legacy, but that's not very useful to use nowadays the the hash the ID of the transfer it's created to to put inside the block. It's the such as 150 bytes, virtual bytes. Okay, and we have the segwit, the most common. It's started with the public key with the number 3. It's such as 100 virtual bytes. And we have the segwit native, what we gonna to create here. It started with the BC1 key, and it have the size such as 70 virtual bytes. And we have the most efficient, it's the taproot with such as 60 virtual bytes of the size, and it started with the BC1B, but we gonna create it, the BC1 key, the segwit. Okay, and why it's important to take a look the size of the hash the ID transfer protocol you are inserting into the box. If we take a look here, the mempool, we can see the fee to pay to insert your transfer to the box to mining. Okay, and we can see it's 10 Satoshi per virtual box, 7 for the if you transfer it in some independent hour, you can pay 2 Satoshis per virtual box or 3. Let's consider we are passing the fee like the 3 Satoshis per virtual bytes. Then, like I said, if we have the legacy started with 1, such as 150, and we are using this box, we need to pay 4 Satoshi. We need to spend 600 Satoshi to make the transfer. Okay, and it's very expensive. So if we use the BC1 key, the segwit native, it represents such as 70 virtual bytes, and paying the fee like the 4 Satoshis, it's dropped to 218 Satoshis. It's the fee to pay the transfer. Okay, it's very little. That is why we are creating the segwit. So let's search it, the segwit address. We have the code in the here. Let's copy it, download the whole file. Let's copy it and paste here. Let's call it the segwit ddr.py. There is the code. It's the code to create the segwit. Okay, with gonna start the public key with the BC1 key. We are not going to code this because this is already done. Okay, we just gonna call this segwit addr to create our code with the public key elliptic. Let's copy the key and let's create the segwit bc1 key dot py. Import hashlib, import segwit.dir. Now we are calling this code the pub key hex. We have just created with the pub key hex this here, the elliptic. Let's convert it to byte again, public key bytes. If you see, we are many time using the byte version, but I'm converting it to hexadecimal to better take a look to the code. From hex, the public key hex. We already know it's converted to the bytes. Now let's create the hash 160. It's the hash, okay? I'm calling it how it's named. Now let's use the hash lib. Let's create the rip AMD 160, the hash lib, the SHA 256. We are going to create the hash. We're gonna pass the public key bytes. Now we're gonna convert it to digest. We are returning it to the binary and returning to the binary the SHA 256 and to the hash 160. Okay. Now we have just calculated the hash. Let's take a look how it's now. There is the hash, the SHA 160. Now let's create the address with the segwit, with the code we have downloaded on the GitHub, encode the Bitcoin 0, the list, and the hash 160. Print the public key BC1Q. It's the address. And there is it, our public key. So that is our public key. With that key we can receive the bitcoins, okay? And if we open this site, the block stream, and pass this public key, we can see if it's validated or not. As you can see, there is the wallet, and it's working. We have 0 UTXO, we have no Bitcoin, we have spent nothing, and nothing is on the min pool. If it's showing to us the wallet, it's because the public key it's working and it's validated, okay? But now we don't have the wallet yet, and the wallet, we can say it's the most important thing, because if you want to send some Bitcoin for someone, you need two things. You need to you need the wallet, and your public key. Okay, now let's create our wallet, and it's called the wife. It's the wallet import format. Okay, so let's call it the wallet wife. We are going to use the hashlib, and we need the public key hex, the one we created, the private key in the beginning. The private key hex, let's insert it on the string. Now we have to pass some steps. Okay, first one, we gonna to introduce the number 80 the number 80 to this string. Okay, let's call it step 1. It's just to insert the 80, the pk. Okay, now the step 2, and the step 2, it's optional, but let's use it to compromise the key. Okay, step 2, it's the step 1 plus 0 1 0 1 in the tail. Okay, now we're gonna create the checksum, the 4 bytes. Let's call it data bytes. We need to convert it to bytes again. Like I said before, everything is used in bytes. Okay, let's call it step 2. I'm gonna call in here. We have here, it's have 64 characters here, 66, and here 68. Okay, now let's create the checksum. I'm calling the hashlib. We're gonna pass again to the hash 5256, and we're gonna pass twice, man. That's crazy. Now we're gonna pass the data, and we're gonna to convert it to the byte twice again with the digest, and we use again, and we are going to take just the 4 first types, and then we pass the beginning to the 4 types, and it's gonna be 8 numbers because we are adding 2 for ounce. Now let's create the checksum final. It's the checksum, converting it to the hex again, and let's print it to take a look. Checksum final. There is it, the 1 2 3 4 5 6 7 8 numbers. We just call it here after the digest. We need that tail, this head to keep going. Now step 3, it's gonna be the step 2 more the checksum final. Okay, I'm taking this step and adding the head in the tail. That's so fucking crazy, man. Let's take a look. There is it. the head of the checksum, it's gonna be the tail of the step 3, like you can see it here. Okay, now import base 58. I don't have it, we need to install it. Okay, the full data, let's again convert it to byte. We always are going to use the byte. Now let's call this step 3, and we're gonna create finally our wallet import format, the width. It's the private key. Okay, now let's pass the basic 64 encode the full data, print wife. There is it in binary, but we can just make the code just to turn off the B and the point key, and there is our private key to use with the public key we just created. With this code, this wallet, I can create the public key, so no one can access the public key, and neither the private key we created on the beginning. Okay, otherwise your cryptos gonna be compromised, and someone can steal it and send to another wallet, and you will never more find it out. And if you lost this Wi-Fi or the private key, you can consider it either that your cryptos are lost on the Bitcoin. So what else we can do? We can create the QR code to access the public key like everyone does. So let's create it. The address QR code.py, import QR code, and I don't have it. Install it. Pip install QR code, and there is very simple. It's this segwit BC1 key. It's the segwit we have created. That's because I'm calling the variable like that. The QR code make segwit, and let's save the name of the image. Let's call it the segwit bc1 key.png. Okay, and we run the code. Something went wrong. What the fuck is going on? No model named build image. Let's install the pip install the pilo. Now there is it created. There is the QR code to receive coins with the segwit we created, and it's going to send to our wallet with. Okay. Now to you understand better what we have done here with the X and Y code, let's make a graphical to understand what's going on with that key to create it or segwit, and it's to validating our wallet or WIF. Okay, let's create graphic.py. Import matplotlib pyplot as plt. I don't have it installed yet. Pip install matplotlib. Hold on. Let's call it the X and the Y. Okay. Now we are going to use the last prime number to the camp of the septic 256K1 to represent the limitation of the graphical. Okay, so I'm gonna paste it, and this number represents the maximum value. If you take a look, it represents that number. It's the maximum value of the graphical. So what does that mean? Let's create it. Let's make the let's normalizing the numbers. Otherwise, my computer will blow if I make a graphical with that such as a large number. So how we can do that? X normalizing. We can pass the X divided by the more large prime number, and the same for the Y. Okay, now it's normalized between the 0 and the 1. As you can see here, let's take a look. The X norm and the Y. There is it, the number between the 0 to the 1. That represent the point in the graphical, the X and Y of my public key. And now plt figure fixed size. Let's create a fixed size C per 6. It's the size. Okay, plt scatter she's norm. We're gonna paste the X value and the Y value to the graphical. Let's call the point the core red, and the size, let's use the 200. plt title, let's call it the X and Y normalized. Into the sec 256K1. Okay, it's the title. plt X label X normalized, and the Y. It's just to watch the graphical in a better way and don't get confused. Let's make the plt X lim. It's the limit. Okay, it's gonna start it with the 0, and the final gonna be of course the 1, but to To take better view, let's use the 1.1 and the Y. Let's make background so don't get all in blank side. Let's create the grid, let's make it the true, okay? And finally, let's show the graphical where it's represent, where our key representing the graphical. It would be that big number, and that's the point which represent my key to create it, the public key, the SegWit, and to validate to the wife, to the wallet import. Okay, the 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 wallet import format. And it represents on point in the graphical just here. It's it's impossible to create it 2 points equal if you don't have the the private key or the wallet. Okay, and there is it. I'm pretty sure, man, you won't find a better explanation of the Bitcoin and the code on the YouTube. So thumbs up, subscribe, and if you have something to say, let's talk about it and type below the video. I'm here to have fun with you fellas. Code, it's awesome, man, it's awesome. So there is it. I hope you have enjoyed. Ta-ta for now.